Bad news for 3I Atlas. NASA remains silent. Images were captured, reportedly some of the clearest observations achieved so far. Yet months later, still unreleased to the public, and now the object appears to have gone quiet. No visible tail, no detectable coma, no apparent activity. There are no stupid questions or opinions here. Join the investigation. This video discusses publicly available research and observations. We explore possibilities, not conclusions. Nothing here claims absolute certainty. We analyze evidence together, following it wherever it leads. Comment anything you notice. We figure this out together. Right now, based on standard cometary physics, 3I Atlas should be brighter. It's approaching closest Earth passage. Solar heating intensifies with decreasing distance. Every comet previously studied becomes more active under these exact conditions according to established thermal models. Instead, observations suggest it appears to have gone quiet. The tail was reported absent in the next session according to telescope observations. The glowing coma that surrounded the nucleus disappeared between observation sessions. Spanish observatories documented this change first. Other facilities confirmed the observation independently using different instruments. That's atypical for comets near peak heating, according to centuries of observational data. Heat drives sublimation in predictable ways. Gas release creates visible tails and comas. Physics supports this relationship consistently, until this object appeared to behave differently from those patterns. Type 1 for natural processes, 2 for alternative explanation. Do you think this is a missing data issue or a missing explanation? NASA's Mars Reconnaissance Orbiter reportedly imaged 3I Atlas on October 2, 2025, according to publicly available mission logs. Files confirmed captured. Telemetry indicated successful data transmission according to standard tracking, but since then have not provided an update yet regarding public release of those specific images. NASA has referenced administrative delays, data pipeline backlogs, and government shutdown effects as contributing factors. Those are legitimate logistical explanations that affect many government operations during such periods. Yet other missions from similar spacecraft typically release observational data within 2 to 3 weeks following standard processing workflows. These images have not been released yet, which is unusual compared to typical timelines. If images reveal something significantly different from predictions, would agencies necessarily release them immediately? Yes or no? Share your perspective. Within 48 hours of NASA capturing those images, according to reported observation windows, China redirected 2 observatory facilities toward the same object. Public records indicate this retargeting occurred during overlapping time frames, different national programs, different stated priorities, same celestial target receiving focused attention. Synchronized timing is uncommon and noteworthy. Space agencies don't typically align observation schedules like this unless a particular target becomes scientifically valuable enough to justify resource reallocation from previously scheduled programs. When independent programs align their instruments, what does that pattern suggest to you? 3 primary hypotheses attempt to explain the observed behavior, and one theory would significantly shift interpretation. First hypothesis, fragmentation. A piece potentially broke away from the main nucleus during perihelion passage when thermal stress reached maximum levels. This represents a well-documented natural process. Cometary nuclei fragment under thermal and rotational stress regularly throughout astronomical history. Second hypothesis, second interstellar visitor. Another object from beyond our stellar system arrived in our neighborhood. statistically rare given only 3 confirmed interstellar visitors ever detected. But if both originated from the same catastrophic stellar event, they could have traveled together through interstellar space before arriving here nearly simultaneously. Third hypothesis, behavior that current models don't fully explain. Activity ceasing precisely when physics-based models predict maximum activity. Brightness variations that appear more regular than typical randomness. Chemistry that differs strongly from the ratios found in solar system comets. Natural objects follow physical laws predictably once we understand their composition and environment. When observations deviate significantly from predictions, that indicates either incomplete understanding of natural processes or potentially different processes operating than we've previously documented. Your comment becomes part of the research archive. If something behaves unlike known comet physics, what would you call it? Now let's examine what information gaps themselves reveal about this situation. Silence itself is a data point, just as much as direct observations when analyzed carefully and without assumptions. Silence can mean uncertainty, not secrecy. Normally, spacecraft observational data follows predictable processing pipelines, captured during observation window, downlink transmission to Earth receiving stations, initial processing, removing instrument artifacts, calibration adjustments, then public archive availability following standard protocols. For 3I Atlas imaging, the timeline apparently diverged from typical patterns. That divergence, considered objectively, represents a point of legitimate scientific curiosity worth examining. Sometimes delays occur for purely technical reasons. Calibration requirements taking longer than anticipated. Artifacts in images requiring additional processing to separate signal from noise. Verification needed to ensure data quality meets publication standards before release. And sometimes delays stem from administrative factors, personnel availability during government operations disruptions, review processes involving multiple organizational levels, coordination between scientific and administrative decision-making structures. No blame or conspiracy necessary, just observation that this particular dataset has followed a different timeline than typical mission results, which raises questions about what factors might explain that difference. High-resolution, close-range imaging potentially reveals characteristics that Earth-based spectroscopy and photometry cannot detect. Surface structures showing formation process signatures. Evidence of internal layering suggesting complex compositional history. Shape characteristics departing from predictions based on gravitational collapse models. Regional variations in surface properties across different areas. If the Mars Reconnaissance Orbiter images show a perfectly typical cometary nucleus matching all predictions, then the extended delay becomes puzzling but ultimately harmless to scientific understanding. Routine confirmatory observations don't typically require prolonged review periods. If the images show characteristics departing significantly from predictions based on earlier observations, then additional verification before release makes sense scientifically. Avoiding premature conclusions about unexpected features serves the scientific process by ensuring accuracy before public discussion begins. Unusual observations need verification to separate genuine phenomena from potential instrument artifacts or processing errors. This represents good scientific practice rather than secrecy. Published spectroscopy reveals something genuinely rare in cometary observations. Carbon dioxide dominating over water vapor by approximately 8-to-1 ratio. Chemistry that differs strongly from the ratios found in solar system comets, where water dominates overwhelmingly. Polarimetry measurements indicated negative polarization values, not just slightly negative. among the most extreme negative polarization values reported from any cometary object in astronomical observational history. This suggests dust particle properties fundamentally unlike standard cometary dust. Photometry detected brightness variations during the active phase, not random fluctuations typical of chaotic sublimation processes. Brightness variations that appear more regular than typical randomness, suggesting some form of regular internal process operating on predictable timescales. These are not conclusions about what the object is. They're documented observations requiring explanation. Clues that don't yet fit together into complete picture using only familiar processes. Fragmentation would explain sudden behavioral changes straightforwardly. Cometary nuclei fragment regularly under thermal stress, well-documented natural process requiring no exotic physics, but timing presents challenges for this explanation. Perihelion passage, when thermal stress peaked, occurred during October 2025. Maximum heating happened then. Observable fragmentation effects would most naturally appear during or immediately after that maximum stress period, according to mechanical models. Instead, dramatic behavior changes apparently manifested months later during March 2026. Why would fragmentation effects become detectable so long after the causative thermal stress event? Delayed structural failure remains theoretically possible, but requires explaining substantial temporal lag between cause and observable consequence. This doesn't rule out fragmentation. It indicates the hypothesis faces timing questions requiring additional explanation beyond simple thermal fracture models. Statistical analysis presents challenges for independent second visitor hypothesis. Confirmed interstellar objects remain extraordinarily rare. Humanity has conclusively identified only 3 ever. 1, Oumuamua in 2017, 2, Borisov in 2019, and now 3 Atlas in 2025. Having 2 such rare visitors present simultaneously within observable range demands either remarkable coincidence or some physical relationship through common origin. Random independent arrivals from completely unrelated sources following coincidentally similar trajectories stretches probability significantly, unless both represent fragments from the same catastrophic event. Stellar collision, planetary system disruption. Something violent enough to eject multiple substantial pieces on interstellar trajectories that remain loosely associated through millions of years before arriving here nearly simultaneously. This scenario requires specific circumstances that aren't common but aren't impossible. Statistical arguments neither definitively support nor rule it out without additional evidence constraining previous trajectories more precisely. When brightness variations that appear more regular than typical randomness, chemistry that differs strongly from solar system norms, extreme polarization, and activity cessation combine in single object, some researchers have suggested exploring whether processes beyond familiar sublimation physics might be operating. This represents scientific hypothesis generation, not conclusion. When observations don't fit existing models comfortably, proposing alternative explanations for investigation is standard scientific method. Testing those alternatives against evidence determines which hypotheses gain support and which get ruled out. Most scientists currently favor natural explanations involving unusual but not impossible conditions. Exotic chemistry from formation around different stellar type, structural properties from different accretion processes, sublimation behavior from compositional layering we haven't previously documented. Some researchers, including Harvard astronomer Avi Loeb, have suggested that when multiple anomalies accumulate, considering whether technological processes might be involved deserves inclusion in the hypothesis space for systematic evaluation rather than reflexive dismissal. This doesn't constitute proof or even strong evidence for artificial origin. It represents philosophical position that extraordinary hypotheses should be evaluated based on evidence rather than rejected based purely on prior probability judgments about what seems likely. The burden of proof for extraordinary claims remains extremely high. Current observations, while genuinely unusual, haven't accumulated to levels most researchers consider sufficient for proposing non-natural origin as most probable explanation compared to natural alternatives that remain plausible. However, keeping all hypotheses under consideration until evidence definitively rules them out represents sound scientific methodology. Premature dismissal of possibilities limits investigation potentially. China's observation timing, if accurately reported, may indicate elevated scientific interest. Space agencies typically don't redirect expensive observatory resources without substantial justification. Oversight committees require compelling scientific rationale for pulling instruments from scheduled observations. When independent national programs apparently decide the same target warrants priority attention simultaneously, that pattern suggests both detected characteristics they consider worthy of immediate comprehensive study using best available instrumentation. What data types might multiple agencies be attempting to acquire? High-resolution spectroscopy, revealing precise compositional details. Photometry with high temporal resolution, tracking brightness changes. Polarimetry characterizing dust particle size distributions and optical properties. Each measurement type constrains possible explanations differently. Coordinated attention doesn't prove anything extraordinary necessarily. It indicates elevated scientific interest from multiple independent assessment processes reaching similar priority conclusions. Examining how the astronomical community responded to One-Eye Oumuamua provides useful historical parallel. Its unusual acceleration, unexplained by visible outgassing, and extremely elongated shape sparked intensive observation campaigns and interpretive debates. Most researchers ultimately favored natural explanations. Hidden, volatile reservoirs producing asymmetric thrust, unusual formation history creating elongated morphology, exotic but natural processes operating. Minority voices suggested considering whether artificial origin deserves serious investigation given characteristics challenging standard natural models significantly. This sparked controversy primarily because the suggestion crossed philosophical boundaries many scientists consider inappropriate without overwhelming supporting evidence. 3. I-Atlas displays different specific anomalies but generates similar patterns. Elevated interest, intensive observation, competing interpretations, some favoring exotic natural processes, others suggesting broader hypothesis consideration. Each anomaly individually might admit plausible natural explanation. Collectively, they create profile requiring explanation that current models don't provide completely satisfactorily. Whether that indicates incomplete understanding of natural processes or genuinely different processes remains open question. You can contribute to understanding by analyzing publicly available data, photometry patterns in archived observations, tail orientation changes between sessions, timestamps from public observatory reports revealing observation coordination, brightness variation analysis, looking for periodicities or patterns. Post your findings. Share your plots and analyses. I read every comment carefully. I pin contributions that add value to collective understanding. Citizen observers have discovered phenomena that escape professional attention historically. Your work matters. Your observations contribute. Your questions challenge assumptions that need challenging. This represents collaborative investigation, not passive consumption of official narratives. Active participation in understanding what this visitor represents and what processes govern its behavior. Let's summarize what observations actually establish versus what remains interpretation and hypothesis. Establish. 3I Atlas arrived from interstellar space on hyperbolic trajectory. Chemistry differs substantially from typical solar system comets based on published spectroscopy. Activity patterns departed from standard thermal model predictions. Recent observations suggest activity declined or ceased when models predicted increase. Uncertain. Why chemistry differs so dramatically? What processes drove unusual activity patterns? Why activity apparently ceased suddenly? What Mars Reconnaissance Orbiter images actually show? Why release timeline differs from typical missions? Each uncertainty admits multiple possible explanations. Evidence doesn't yet constrain possibilities sufficiently to reach definitive conclusions that all researchers would accept. This ambiguity frustrates people understandably. We want clear answers. But science often operates in gray zones, where data permits multiple competing interpretations, and certainty remains elusive until additional evidence accumulates. Scientific progress depends fundamentally on open data sharing. Multiple independent researchers analyzing the same observations, diverse perspectives contributing interpretations, collective intelligence often exceeding individual expertise. When observations face extended restrictions, that limits the scientific process. Fewer researchers can analyze. Fewer perspectives get applied. Understanding advances more slowly than it would with full transparency. Avi Loeb's characterization of the delay as scientifically unacceptable reflects this principle. When rare observations of objects from beyond our stellar system get captured by publicly funded instruments, transparency serves knowledge advancement better than restriction, regardless of what images actually show. If images confirm predictions showing typical cometary nucleus, release allows community to verify that interpretation. If images show unexpected features, release allows broader expertise to contribute analysis and interpretation. Either outcome benefits from transparency. 3. iAtlas represents genuine scientific mystery, regardless of ultimate explanation. Whether ancient relic carrying preserved chemistry from early galactic conditions, or fragmented comet revealing internal structure, or independent visitor demonstrating that interstellar objects are more common than detection rates suggest, or something incorporating processes we haven't yet properly characterized, the information gaps, the extended timelines, the coordinated attention from multiple agencies, all create an environment where speculation naturally emerges to fill spaces left by missing data and analysis. Your continued engagement drives understanding forward. Comment theories and observations. Question assumptions when they seem unsupported. Share analyses of public data. Challenge interpretations that don't match evidence comprehensively. Together we push toward better understanding, following evidence carefully without premature conclusions, acknowledging uncertainty while working systematically to reduce it through additional observation and analysis. This represents how discovery works in modern connected era. Not through official channels exclusively, through distributed networks of engaged observers, through communities refusing to accept information restrictions without justification, through collective analysis, valuing every legitimate contribution. The mystery continues evolving. Observations continue accumulating. Analysis continues refining hypotheses against evidence. and community participation continues, contributing perspectives that advance understanding. Comment your interpretation of the evidence. What processes do you think best explain the observational patterns? Where do current explanations face challenges requiring additional work? Like this video to help it reach others interested in following this investigation as it develops. Algorithm responds to engagement. Your like makes content visible to broader communities searching for analysis of these observations. Subscribe as soon as information emerges, whether through official release or independent observation. This community will analyze it immediately. When data appears, we examine it together. 3. IATLAS change behavior suddenly. NASA's image release timeline differs from typical patterns. China apparently elevated observation priority, and within those facts and information gaps lies the answer to what this visitor represents and what processes govern its behavior. We investigate together, following evidence carefully, acknowledging uncertainty honestly, working toward understanding systematically rather than jumping to conclusions prematurely.